our faculty, Mr. Shiva. Shiva, over to you.
Thanks, Ganguly. I think all of them are able to hear me now. Uh, Good evening or good morning to everyone. I don't know from which part of the world you are from, but anyway, good evening. So my name is Shiva. I'll be uh, taking this webinar forward. First of all, before we go ahead, I would like to set the expectations on what we are going to cover in this first 2 hours. So firstly, let me talk about the expectations. Firstly, we'll actually start with understanding problems of a traditional monolithic application, then how microservice architecture can solve the problems. Then we are going to understand about advantages and disadvantages of microservices. Actually, microservice architecture is not good for all. There are some advantages and disadvantages. We'll discuss about them. Then mostly I'll focus on problems in microservices. If you are implementing microservice architecture, what are the challenges you are going to face and what are the alternatives to overcome these challenges. So in that process, I'll introduce what is a discovery server, and we'll see or discuss how to use Eureka and Console as discovery server. Then I'll discuss about how you can register your microservice in a discovery server and how to look up discovery server. Once we understand about discovery server, I'll also discuss about the problems of server-side load balancing when you are implementing microservice architecture. Then we'll come up with a solution called as client-side load balancing. We'll see how to leverage ribbon for achieving client-side load balancing. Okay. Then once we understand about ribbon and once we understand about client-side load balancing, we'll discuss about various problems we can see in distributed computing. So to solve some of the problems, we'll understand what is a circuit breaker and how to use this tool Hystrix, the tool from Netflix, as circuit breaker. Once we understand how to use Hystrix as circuit breaker, we'll discuss about what is the necessity of API gateway and how we can use Netflix Zool as an API gateway. Then, once we understand about the role of Zool, we'll discuss about how to centralize our configurations of all microservices in configuration server. Then we'll understand in microservices, tracing your requests is a big problem. I'll introduce you to what is Sleuth. A Sleuth is a library which we can use for log tracing. Once we understand about Sleuth, I'll also discuss about how to stream logs to another software called as Zipkin and how we can analyze logs to find some performance issues using Zipkin. So that will be the agenda. And after I discuss all the concepts, I will show you a simple demo on how to start Eureka as a discovery server using Springboot, and then how to register your microservice in Eureka and how to look up Eureka for your microservice. So that will be the agenda. So I'll take 1.5 hours almost to discuss all these and I'll show a demo. In last half an hour, most probably I'll keep it for question and answers to take any of your queries, and I hopefully can answer all of your queries. Okay, let us get started. First, we'll discuss about monolithic application. I don't like to run through presentations mostly, so I will draw diagrams on screen and I'll explain you. Okay, so what is this monolithic application? monolithic application is a single application which contains all the functionalities. If in your application, if you have 10 functionalities, 10 use cases, and if you're developing a single application for all the use cases or functionalities, we can say that you have developed a monolithic application. Take an example. Let's assume that I'm developing an application for an online portal like say Flipkart. So when I say online portal like Flipkart, in Flipkart, there might be a lot of use cases or functionality. Maybe we need one service for search service. There might be one more service for cart management, one more service for checkout, like that. So we can have multiple services, one more service for checkout, one more service for catalog management. Like that, if you take an example of an online shopping cart application, there will be a lot of services. I just listed only 4 right now. If you are developing a single application with all these services, then I can say that this is a monolithic application. Traditionally, from years, we have been doing the same. What we used to do is we just create a WAR file, a web archive file, which contains all these functionalities, and we used to deploy. So now let us use the same context and discuss what are the problems of such monolithic application. The first problem I would say is, if you are developing such a huge application, you have a lot of code base, right? And one problem I see in most of the product based companies is they have a lot of huge code base. And if I am a new team member who is joining your team, how many weeks or even months do you think it will take for me to become productive? What I mean by productive is I should be able to fix any of the bugs in your application with confidence. So I have asked in many companies, they would say, even after 1 year also, I would not be mastering the whole code base because the code base is so huge. I don't know. If I make some modification in one of the service, it might impact other service. That means I can say that if we are having a single monolithic application with huge code base, the developer is not productive quickly. That is one problem with monolithic application, right? So if I can decompose this single monolithic application into individual services, individually deployable, individually manageable, individually scalable services, let us see what is the advantage I'm going to get. So suppose if I decompose my online shopping cart application into separate small applications. Let's assume that I have one application which is implementing only search functionality, another application which is implementing only cart management, another application which is implementing only catalog management. Like that, if I can decompose my big monolithic application to small applications which are handling only small functionality, what I can do is, suppose if there's a new team member who is joining your team might be working on maybe two such small applications. These 2 small applications might be having a less code base. So if a developer is joining your team, he can definitely become productive within a week. That means if you are going with microservice architecture, if you are actually decomposing your monolith into microservices, then I can say that developers can become productive quickly. That is one advantage. Another advantage, let us compare with monolith again. Assume that this is my monolithic application which has all the services in single application. Take an example of online shopping cart like Flipkart or Amazon. let's assume that for Amazon application, there are 1,000 requests coming for search. Out of 1,000 requests coming to Amazon for search, how many items do you think will be added to cart? Probably, I can say out of 1,000 searches, probably 10 or 20 items may be added to cart. 20 carts might be full. Out of 20 items added to cart, if I ask you how many will go for checkout, probably 3 to 4 will go off for checkout. That means out of 100 requests coming to search service, cart service is getting only 20 and checkout service is maybe getting 3 to 4. So maybe if I'm expecting more number of search requests, my single web application is not going to serve all the requests. So maybe I need to scale up my number of instances of my monolithic application. So if I'm having a monolithic application, I end up scaling the whole monolithic application. Instead of only scaling search service, I end up scaling only the whole monolithic application. That means, can I say that scaling is not perfect? Scaling is not effective in case of monolithic application? Yes. Suppose if I've taken microservice based approach, what I could do is, as my search service is an individual application, maybe I can start say 50 instances of search service, maybe 5 instances of cart service separately, and maybe for checkout, maybe 2 to 3 instances of checkout service. So what I mean to say is, you can scale your individual microservices independently. So that means I am able to utilize my hardware resources efficiently for scaling, right? This is another advantage of microservice architecture. Okay, and I'll tell you one more problem with monolith. Let's take another example. Suppose if I'm having a monolithic application which has 3 services. Assume service 1, let's assume that it is doing a lot of CPU intensive operations. It requires more CPU. And service 2, let's assume that it is doing a lot of memory intensive operations, so it requires more memory. And service 3, let's assume it is doing a lot of read write. That means it needs high IO devices. So if I am deploying a monolith which contains such 3 services, on what type of hardware do I need to deploy my monolithic application? I need to deploy on a machine which is having high CPU power, high memory, and high IO. Yes, that means my hardware cost is increasing a lot. Yes. If I can decompose this monolith into microservices, what I could do, I could deploy this service 1 on a machine which is having high CPU power. I can deploy this service 2 on a machine which is having high memory, and I can deploy this on a machine which is having high IO. That means a machine which has some good hard drives with faster speed, SSD drives maybe. So in this way, am I not utilizing the available hardware efficiently? Yes. This is one of the advantage of microservices. So if I can just go on listing all the advantages, there are a lot of advantages of microservices over monolithic application. But that said, microservice architecture is not good for everyone. So I'm a pessimist actually. Whenever I want to use something, instead of looking at advantages, I'll always see what are the problems. So let us see what all problems I'll face if I'm going with a microservice based approach. Okay. So take an example. Let's assume that I have two services. I'll take very generically. I have two services, service 1 and service 2. Definitely when we are going with microservice architecture, for each service, I might be deploying n number of instances. Assume that I have deployed 5 instances of service 2. Now, assume that there are n number of instances of service 1 as well. What I want to achieve is my service 1 needs to make a call to service 2. So definitely when one service wants to talk to another service, they should be exposing some contract, is it? So assume that service 2 is exposing a REST API and service 1 wants to consume that REST API. Okay. Now service 1, how can it make a call to service 2? There are 5 instances deployed on different machines. Maybe each instance is having its own base URL. The IP ports are different. How can my service 1 hit one instance of service 2? How does it know how many instances are there? Maybe at this moment there are 5 instances, but I may end up scaling to 10 instances later. So in S1, I cannot hard code the IPs and ports or URLs. It's not a good idea. So what is the solution? Traditionally, we have been using a server-side load balancer for the same, right? So let us actually see what will happen if we use server-side load balancing in this use case. So normally if there is server-side load balancer, what we do is when S1 wants to hit any of the instance of S2, S1 will hit the load balancer and load balancer will use some algorithms to hit one of the instance. This is the typical scenario, right? But let us see the problem. Actually, when this service 1 and service 2 were part of a single monolithic application, whenever service 1 wants to call service 2, it was a local in-memory call? Yes. When I decided to go with microservice architecture, local in-memory call will become a remote call because service 1 has to make a remote call to service 2. Okay, we understood that these are the challenges, we went ahead. But again, when I introduce server-side load balancer, what will happen? Whenever service 1 wants to call service 2, first from service 1 to load balancer is one network call, and load balancer to another instance is another network call, 2 network calls. Actually, if you see the performance issues in most of the applications, performance issues are not because of running some extra lines of code. Our CPUs are so fast nowadays, executing extra lines of code is not at all a matter. Mostly the performance bottlenecks which we see in our applications are because of I can say because of a lot of IO or networking issues. So in this case, if there are 2 network calls, I will definitely see a good impact on performance. Oh, actually, I felt that monolithic was not good, and if I go with microservices, now I started seeing problems. In-memory call in a monolithic application now is translated to 2 network calls. I may see a lot of performance issues, right? So when one microservice wants to call another microservice, server-side load balancer is not a good idea, right? So then what is the idea? Actually, there are some companies like Netflix who have implemented this microservice architecture long back. And initially this Netflix, they thought they can use a server-side load balancer between microservice instances. After doing a lot of load testing and all, this Netflix has identified that server-side load balancing is not giving good result. So they introduced a concept called as client-side load balancing. Okay, so let us discuss about what is client-side load balancing. Now, I'll tell with an example. If you want to go with client-side load balancing, let's take an example. I have two services. Service 1 and service 2. Each service might have multiple instances. So if you want to implement client-side load balancing, we need another software called as a discovery server. What is this discovery server? Let me introduce it. You can think of discovery server as a REST API. What is the purpose then? Whenever any of the microservice instance is starting up, the microservice instance has to go and register itself with a discovery server, maybe with a unique name, with a name. So whenever any microservice is starting up, whenever any microservice instance is starting up, they will have to make a REST API call to discovery server and ask the discovery server to register. Okay. So in this case, service 1 also needs to go and register with discovery server. If there are 10 instances of service 1 also, every instance should go and register with discovery server. Okay. But now the questions are, if service 1, if 10 instances of service 1 are registering, do you think each instance will register with a different name? No, right? All the instances of service 1 should register with same name. So what you can do is, you can think of discovery server maintaining a map. In the map, the key will be the service name. Let's say S1, and the value will be a list which contains the details about all the service instances. So if there are 5 instances of S1 started, the list size will be 5. All of the 5 instances will register with same name S1. So when I said when they are registering, they should make a REST API call. Basically, it's a post. The service will make a post request to the discovery server's REST API and send some data like what is its IP, what is its port, protocol to communicate, all these details, right? Similarly, when S2 is registering, S2 also will register with a unique with a name. All the S2 instances will register with the name S2, and the value will be a list. So if there are 10 instances of S2, the list size will be 10. So basically, discovery server is maintaining a registry of all the instances. Okay, that's good. Now, once we understand what is discovery server, what it is purpose. Now, let us take a use case. Service 1 wants to make a call to service 2. Whenever service 1 has to make a call to service 2, what it has to do is service 1 has to look up the discovery server and ask the discovery server, hey, give me all instance details for a service with name service 2. So the discovery server will give a list of 10 instance details. Yes. Now S1 has got the information about all the 10 instances of S2. This service 1 has to use some algorithm to find out one of the instance and hit that instance directly, right? That means which instance of S2 to hit is decided by some logic on S1. Can I say S1 is a client to S2 in this case? Yes. So the algorithm which will select S2 instance is running on the client side. The load balancing algorithm which will decide which instance of S2 to hit is running on S1. So that means in this case, are we not using client side load balancing? Yes. So is my problem really solved? I don't think so. The problem is not solved. Why? What was the main problem when I was using server side load balancer? I said whenever S1 wants to hit S2, there are two network calls. That's the reason why I thought I would use a client side load balancer. But when I am going with this scenario also, whenever S1 wants to hit S2, how many network calls are there? Two. First of all, S1 has to look up discovery server, get all the instance details, then use an algorithm to find one of the instance and hit service 2, right? So again, two network calls. Then how is the performance improved? I'll put the same idea of a discovery server with a small twist. Let us see. Okay, again, I'll draw a diagram. Let's assume that this is a discovery server and this is service 1. And let's assume that for service 2, there are n number of instances. Okay. Actually, I said whenever S1 wants to call S2, it will look up discovery server, right? But now I'll change my word. Assume that in S1, there will be background thread which will be running at regular intervals. This service 1 can look up discovery server at regular intervals, get the registry and keep a cache of registry on service 1. So assume that this background thread is syncing up with discovery server after every 30 seconds. After every 30 seconds, the background thread will get the registry and cache it. Now, whenever S1 wants to hit S2, S1 what it will do now? It will look up in the local cache, get all the instances, use some algorithm to decide which instance to hit, and then hit S2, right? So there is only one network call now. If I am using this approach of client-side load balancing, yes. So actually, Netflix, the companies like Netflix, they have tested out this client-side load balancing, and they have found out that client-side load balancing in case of microservices is giving positive results, right? So we understood the importance of client-side load balancing. Okay, I understood the importance, that is fine. But do I need to write my own discovery server software? Do I need to write algorithms on client-side load balancing? Oh, if I start writing all that, instead of concentrating on my business logic, I will end up writing something else. So what we can do is actually Netflix, they have put a lot of their effort in, and they have written their own discovery server called as Eureka. And they have made it as open source. What I can do is I can use this open source Eureka as my discovery server. And also in Netflix, they have spent a lot of research and they have created a library called as Ribbon. In this library, they have already created a lot of load balancing algorithms. So I don't need to write my own load balancing algorithms. I can just leverage Netflix Ribbons library to achieve client-side load balancing, right? So I'll not write logic. Maybe I'll just do some configuration on Ribbon to achieve load balancing. I'm very happy. Now I can concentrate on writing my business logic, right? So now you understood about the role of Eureka and the role of Ribbon. I'm a pessimist. The problems are not yet solved. I'm going to present you with a lot of problems, and we are going to discuss with the solutions. Okay. Maybe let me present you one problem first. Let's assume that with Eureka, there are 10 instances of S2 registered, right? What will happen if one of the instances of S2 crashes? Actually, I would like to tell you one more thing. When we are going with microservice architecture, am I developing a distributed application? Yes, we'll have a lot of services distributed over the network. So since we are having a distributed applications, we have to change our mindset. Failures are common. A failure can happen at any point of time. So we should design our application to face failures, right? But now, how do I handle failures? Let us see now. We were discussing that what will happen if one of the instance of S2 fails, crashes, right? How does Eureka know that this instance crashed? Because Eureka's registry has to be updated, is it? Somehow Eureka should be able to know that this instance crashed. So actually what happens is, whenever any microservice registers with Eureka, at regular intervals, the instance should send heartbeats. What do I mean by a heartbeat? If I go to low level, I can say heartbeat is again nothing but one more REST API call to discovery server saying that, okay, I am up, I am alive. Is that? It's just a REST API call, updating Eureka, right? So every microservice should be sending heartbeats to Eureka at regular intervals. Oh, and I said regular intervals, what should be the interval? If I set the heartbeat interval as 1 second, lot of instances will be sending heartbeats to discovery server and the discovery server may crash. So to less renewal interval, the less the heartbeat interval, the more number of requests will go to discovery server. So Netflix has done a lot of research and they came up with a number called as 30 seconds. So if after every 30 seconds, my microservice should be sending heartbeats. Okay. Actually, I'm getting a lot of questions from many of you. Thanks actually for these questions. Yeah, but let me complete my discussion. Last half an hour, I will actually dedicate on question and answers. So then you can shoot out all of your queries, right? Yeah, so I will not take the questions right now. Of course, you can keep your questions typed so that in the last half an hour, I will take up all the queries and answer one by one. Okay, so let me go further. Heartbeats, every instance should send heartbeats, right, to Eureka. Yeah, as some of you has pointed in your questions, Eureka is not only the discovery server. There are a lot of other discovery servers also, like Consul from HashiCorp, or even we can use Zookeeper also for the same purpose. There are a lot of discovery servers, but let us concentrate with one of the discovery server, because once we understand about one discovery server, the concepts will be same for anyone, right? So in this webinar, I'm going to concentrate on the whole Netflix stack. Okay. So coming back, the S2 instance, all instances of S2 will be sending heartbeats at regular intervals, let's say 30 seconds. Okay. Then if one of the instance crashes, Eureka will not get heartbeats from the instance. So Eureka will be able to identify, okay, this instance is down, right? And update its registry, the cache, right? But the question is, if just one heartbeat is missing, do you want Eureka to remove the information from registry? May not be correct, Because if one heartbeat is missing, it might be due to various reasons like network failure also. It can be possible that the instance is up, but because of some network issues, the heartbeat didn't reach Eureka, right? So just if one heartbeat is missing, Eureka should not remove the details from the registry. Then what? What will happen if 3 consecutive heartbeats are missing? Then it may be good, right? So if 3 consecutive heartbeats are missing, then Eureka will remove the registry, the details from the registry. 3 heartbeats means what? In this case, 90 seconds. So if one of the instance of S2 crashes until 90 seconds, my Eureka will say that the instance is up. Okay, let's say after 90 seconds it gets updated. Now this S1 is having a background thread which is syncing up after every 30 seconds, right? That means 90 seconds plus 30 seconds. That means a maximum of 120 seconds it may take for S1's cache to get updated. Is it? If in this 120 seconds, what if the algorithm of S1 is selecting the instance which failed and making a request? This is a failure. So S1 will get 500 status code. That means S1 also will fail because of S2. Then what is the solution? Solution might be, I don't want S1 to fail because S2, one of the instances of S2 has failed. It may be a good idea to retry to the next available instance. Yes, there are a lot of other instances which are up. So it will be good if my service 1 can retry to the next available instance. All right, makes sense. But how many times should this S1 retry? There should be some maximum number of retries, right? S1 cannot keep on retrying to the available instances. So my service 1 should retry until some timeout. If timeout has occurred, then service 1 should not retry. Then what happens? What if somebody has made a call to service 1? Service 1 is making a call to service 2. It retried until timeout. It didn't get any response. Then do you want S1 to fail? Probably not. We don't want service 1 to fail because of service 2. Then what is the solution? Let me put the same thing in a different way with a good example. Let's assume that we are working on some online shopping cart application like Flipkart or Amazon. So I want to purchase an iPhone. I searched for iPhone on, say, Amazon. Whenever I search for iPhone, actually Amazon also gives me some recommendations, is it? Maybe iPhone is too costly. It will give some recommendations for other phones with similar configuration, right? This is a feature of any of the e-commerce based application. So let's take this example. Assume that in my application, I have 2 services, search service, search service, and recommendation service. So search service, recommendation service. Let's assume if a request comes to search service will actually search for products, and also let's assume that search service is making a call to recommendation service. Recommendation service should give the recommendations also. Then assume that search service is aggregating the results and giving both search results as well as recommendation results. Let's assume that this is a scenario. What will happen if there are multiple instances of recommendation service, right? Search service try to hit the recommendation service instance. This is down. It retried. This is also not giving a response. Retried. In the meantime, timeout occurred. Do you want search to fail because recommendations failed? Probably not. So if you search for any product and if you see a search failure, that website is not trustable, right? So probably we don't want our search to fail if recommendation service fails. What we have to do is we have to actually have a mindset. Failures are common. So when failures are common, we should make sure that there should be some fallback logic. Fallback. When search service is not able to hit recommendation service, it should be able to execute some other fallback logic. Maybe the logic which will get the recommendation from a local cache and give the results back. Right? So what I mean to say is failures are common in any distributed application. We should be able to execute some fallback and return gracefully. Right? So that is one approach. Okay. So how to execute the fallback? How to achieve all this? I'll discuss. Okay. But few more problems. Let us see when you are using client-side load balancing. As I said, if I'm using client-side load balancing using ribbon, I don't need to write any code. Ribbon, we can just configure it, and ribbon will take care of load balancing, retries, everything. So using ribbon itself is not solving the problems. Even after retries also there might be a failure. So we want one more solution, right? To discuss about solution, I'll present the same thing in another way. Let's take this example. In my application, I might have multiple services. Service one might be dependent on service 2. Service 2 might be dependent on service 3. Service 3 on service 4, and service 4 on service 5. Assume that we have such dependent services. Service 1 is calling service 2, service 2 is calling service 3, service 3 is calling service 4, service 4 is calling service 5. Maybe service 2 also is dependent on S5, S3 also might be dependent on S5. Can I say that all these services are interacting with each other and they're forming a circuit? Yes. All the services are connected to each other as a circuit. It is possible that S5 may fail due to various reasons. If S5 fails, S4 will fail, S3 will fail, S2 will fail, S1 will fail. That means one failure will result in cascaded failures if I don't take proper care, right? So for whenever you are making any service call, you should be ready with a fallback. So whenever S4 is making a call, it should have a fallback logic. Whenever S3 is making a call, S3 also should have a fallback logic if S4 call fails. S2 also should have a fallback logic. S1 also should have a fallback logic to be executed. You have to implement it in such a way, right? So once you understand this, let me use a terminology. All the services are connected to each other as a circuit, right? So if one of the service is down, can I say that the circuit between these services is broken? Yes. Whenever a circuit is broken, we want a fallback logic to get executed. Actually, to identify what is the status of circuit between two services, we might need to consider a lot of scenarios actually, right? So actually there's a design pattern called as circuit breaker design pattern. We might need to implement this circuit breaker design pattern to understand what is the status of circuit between service 4 and service 5. If the circuit breaker implementation says that circuit is open means I want to execute the fallback. If the circuit is closed, I want to make a call. So I need to implement a pattern called as circuit breaker pattern. But why should I write such an implementation of such pattern? It will be good if there is any library which is implementing it. So again, from Netflix, there is one more library called as Hystrix. Hystrix is a library from Netflix which is implementing circuit breaker pattern. So what we can do is we can leverage Netflix Hystrix and we can implement this fallback logic and circuit breaker, right? Okay. I want to throw more light on circuit breaker because many people who are even working on circuit breaker does not know the real usage of circuit breaker. I would confidently say that many of the people will feel that circuit breaker is for identifying whether circuit is open and executing the fallback. No, circuit breaker is not for this simple reason. Let me elaborate and spend some good amount of time on circuit breaker. Okay, so this needs more explanation. Let me just tell you a very good scenario. Just concentrate for next 5 to 10 minutes. You'll get a very good understanding. And if you have any queries, I'll take your question at the last. Okay. So let's take an example. I have my service 1. I deployed the service 1 on some web server, let's say Tomcat. Let's assume that my service is running inside a Tomcat. Whether it is an embedded Tomcat or an external Tomcat, let us not discuss right now. It's running inside Tomcat. Okay. So whenever a new request comes to your application, don't you think that a new thread will be created by Tomcat to handle that request? Yes. Do you think a new thread will be created for every request in Tomcat? No, right? So basically, Tomcat will be having a thread pool. If you have to create a new thread for every request, it will be so costly in terms of CPU resources and all. So Tomcat will be internally using a dedicated thread pool for serving the requests. Let's assume that my Tomcat has a thread pool of size 200, just for an example. And every thread pool also will be maintaining a queue also. Let's say the queue capacity is 50. What does this mean? My service 1 can concurrently handle how many requests? 200 concurrent requests, right? Maximum number of threads in my pool is 200. So concurrently, my service 1 can handle only 200. If all the threads in the pool are busy, what will happen if one more request comes? The request will be kept in a queue, is it? The queue size is 50. Okay. Assume that the queue also will be full. All the requests are kept in a queue, right? The queue also is full. All 200 threads are busy. My queue is also full. Will my Tomcat be able to accept any more new requests? No. Tomcat will reject the requests. This is one problem, right? Now let us take this to the next level. Okay. If I have to take this to the next level, I can say that first of all, in this case, the maximum capacity of my service 1 is it can handle or it can accept 250 concurrent requests. In this case, 200 plus 50. It can handle 250 concurrent requests, but at a time 200 can be processed. 50 will be in the queue. Keep it in mind, right? Okay. Now take this example. In this case, let's assume that there are multiple services which service 1 is dependent on. Service 1 is dependent on service 2, service 3, service 4. Whenever request comes to service 1 for accomplishing one use case, assume that service 1 is making a call to service 2, waiting for response. Then it is making a call to service 3, waiting for response. Service 4, waiting for response. And assume that due to some reasons, S4 is very slow. This is very slow. Service is up, but due to some reasons, it is very slow. So what will happen if a request comes to my service 1? A new thread will be dedicated to this request. So single thread will make a call to S2, S3 and S4. And since S4 is slow, my thread will be waiting for S4 for longer time. And what will happen if 200 concurrent requests came? 200 threads are actually busy, and mostly the 200 threads are busy because of waiting for service 4. Is it? That means, can I say that just because S4 became slow, my S1 also is becoming slow? And all the threads in my S1 are utilized for S4. It cannot now accept any more requests, right? This is one problem. One slow service in the system can result in breaking of other services. Like this, in this case, service 1 has broken down. All the 200 threads will get exhausted in little amount of time, right? And service 1 will not be able to accept any more requests just because of what? There is no code problem in service 1. Just because of S4 is slow, just because of S4 is slow, S1 also became slow, and S1 became not responsive after some time. This is one problem. How to fix this problem? Let me introduce you to a pattern called as bulkhead pattern. Bulkhead. What is this actually bulkhead? I will explain this bulkhead pattern using a very good familiar example. Actually, this bulkhead, we actually hear this bulkhead in companies who are manufacturing ships. Ship manufacturing companies will be using this bulkhead a lot. Let me talk about a very good scenario. Our famous Titanic. Why Titanic sank in the sea? Because it has hit an iceberg. Do you think Titanic is so weak that just because of one hit in iceberg made the Titanic to sink? Actually, I would say that there was a manufacturing defect, or there was a problem in the Titanic design. Just because of one iceberg, the whole big ship crashed. So I would say that if they've taken a proper care, Titanic could not have sank. What do I mean? So let's say you have a big ship which is going in the water. If there is a small hole in the ship at the bottom due to some reason like hitting an iceberg or whatever, what will happen? The water will come into the ship gradually and the ship is going to sink. Just because of a small hole somewhere, the whole ship is sinking. It's not a good idea. The ship is not designed properly. So normally what they do in ships is they have layers actually. They have a layer where they have a lot of layers, not one layer, they have a lot of layers of layers in the ship, where if one hole occurs at one part, this layer will shield the other part. It will not let the water go into other parts. This layer will shield. So water may enter up to this part. It will not cross this part. Even if this part also is having a hole, due to some reasons, again there will be one more layer where the water, it will not allow the water to come into this one, right? So basically in ship, they will have a lot of compartments where if one of the compartment is having some problem, it will make sure the water will not come into the other compartments. If Titanic was designed in such a way, then it might not have crashed. I'm not saying that about Titanic, but just to give a good example in this case, right? That means what? We are just limiting the failures to only one compartment. The failure will be only in one compartment, and that compartment should shield from other compartments, right? So applying the same pattern here, we say that the ships should have a bulkhead, a big head, where if there's a hole in one part of the head, right, the ship should not sink. So we say that ships should have bulkheads with a lot of compartments. Okay, now coming back here to this example of service 1, service 2 and service 3, I'll draw a simple diagram. In service 1, what I would suggest is, let the service run inside Tomcat have 200 thread pool. This is the thread pool of service 1's Tomcat. Assume. Now what I will do is, whenever new request comes, if service 1 has to make a call to service 2, what I would do is I would restrict that whenever service 1 is making a call to service 2, I would restrict that it should be using only 20 threads. Basically what I will do is I will create one more thread pool of size 20, let's say. One more thread pool. This 200 thread pool is different. I'll configure one more thread pool of size set 20 and dedicate this for S2 invocation. So whenever service 1 wants to make a call to service 2, the main thread from this pool should not make a direct call. The main thread should submit this task of making a call to another thread pool of size 20. Okay. So what will happen if all the 20 threads are busy? Actually what? Let's assume 20 requests came to service 1 and 20 threads from this 200 submitted the task to another thread pool. That means these 20 main threads are waiting for the response from this 20 threads in service 2. Right? Now in this case, how many threads are blocked from the main thread pool for service 2? Only 20. So among 200, only 20 threads will be dedicated to service 2 invocation. Is it? And the main threads will be waiting for these 20 threads to join back. Is it? Yes. So in this case, I can have, let's say service 1 may want to invoke service 3. Maybe may want to invoke service 4. What I could do is, on S1, I can have 3 more thread pools, 2 more thread pools. Maybe I will dedicate another thread pool of size 10 to S3, another thread pool of size 30 to S4, right? For S4 invocations, I have a dedicated thread pool of 30, for S3 10, and this 20. So totally how many threads I have? 200 is a main thread pool, 230, 240, 260 threads will be used maximum. So how many thread pools do I have? 4 thread pools I have. So in this case, what I did is, actually if the service 2 is slow, how many threads from the main thread pool will be blocked? Waiting for service 2? 20, maximum 20. That means even though service 2 became slow, it didn't eat away all my 200 threads, only 2 threads, right? Now the advantage is here, you can see one advantage. Now you may ask me, hey, why are you having a separate thread pool for invocations, right? The idea is one main thread will be submitting a task and it will wait for response from the other thread, right? What if the service 2 is very slow, this thread never returns even after say 30 seconds also? Do you want the main thread to wait for more than 30 seconds for response? No. What I could do is, I can make my main thread of S1 to wait for S2 until some read timeout. Maximum my S1 will wait for S2 for the result from S2 until read timeout. If read timeout has passed, let's say read timeout is 30 seconds. If read timeout has passed, what will happen? The main thread will just have to execute a fallback. My main thread has to execute the fallback and return gracefully, right? In that way, I can have a timeout, right? Maximum timeout of 30 seconds. My service 1, whenever it is making a call to service 2, it will wait for a maximum timeout of 30 seconds, right? If the main thread itself is making a call, the main thread from the original thread pool itself is making a call, there is no way to implement this read timeout, right? So that is the reason why we say there should be some dedicated thread pool for each service invocation, right? My S1's main thread, what it will do? It will submit the task to H2 and will wait until read time for response. If the thread does not come back with response within that time, I can say that my S1 will execute the fallback and return gracefully, right? Okay, so that is the idea. So Hystrix is implementing this bulkhead pattern also, so that my service 1, all the threads of my service 1 will never get exhausted because of one slow service, right? If the service is slow, my Hystrix, what it will do? It will time out and will execute the fallback. Okay, any doubts? I think it should be very clear. Maybe actually I would say that Hystrix is a very confusing topic. Nobody understands this Hystrix in a correct way, but I guess I have taken a very good example and I was able to give a good idea about how we can configure threads at each service invocation level and how to implement this timeout. And actually in Hystrix, there are a lot of other scenarios also to be discussed. But for this webinar, I cannot discuss a lot of other problems which Hystrix will solve. So I will just stop my discussion on Hystrix at this level and we'll go to the next thing in the agenda. So we completed up to Hystrix. Let us talk about what is the role of a gateway in microservices. Okay. So let's take an example. Again, in my monolithic application, let's say I have some services from service 1 up to service 20, and each service is having 555 instances. So totally how many instances I have? 20 into 5, 100 instances I have. Okay, let's assume that my microservice based application is running and we have 100 total instances. Now the thing is, I have service 1 to service 20. Each service will be exposing a REST API, right? And why do you implement all this? You want your services to be exposed to outside world, also to the clients. Client application should be able to consume your application services also, right? Now the point is, do you want to expose all the services from S1 to S20? May not. Maybe I might want some of the services to be internal purpose. I don't want to expose all 20 services, right? So the good idea is, maybe I might write some 3-4 orchestrated services. I might write some service 21 to, let's say, 24, 25. Maybe I'll write 5 services. What they do is, these services may interact with other services internally and they are exposing some functionality, right? So maybe I don't want to expose all S1 to 20, S20. Maybe I want to expose only some few functionalities through S21 to S25. So whenever any client wants to achieve some functionality, they should be able to make a call to one of these 5 services. These services will internally talk to all S1, S2, S3, whatever it is, and then give the result back. Okay, this is the pattern which we follow. We don't want to expose all of our microservices to the external client. We expose only few orchestrated services, we say. Okay, but then how many instances of S1 do you want? Maybe for this S21, I might be having some 5 instances. Okay, how does this external client hit your S21 or S22? There are multiple instances for each service. Do you want the client to look up your Eureka? Let's say this is your Eureka. All the instances are registered with Eureka. Do you want your client to look up Eureka? Get all the instances of S21? And do you want the client to use something like ribbon for doing client-side load balancing and hit one of the instances? Not a good idea. Why do you want to expose all of our internal architecture? Why do you want your client to know that you are using Eureka? So client should be abstracted. Will it not be good if there can be a proxy, right? So if there can be a proxy, whenever any client wants to hit any of your microservices, client will hit the proxy. Proxy, if this proxy is an intelligent proxy which can look up Eureka, get all the instances of your service, and if this proxy can use, say, ribbon for doing client-side load balancing, identify one instance and hit it. Good, right? The clients just need the proxy URL. Whenever any client application want to hit any one of the microservice, any one of my microservice, they will just hit my proxy, and proxy will take care of looking up Eureka, getting all the instances, load balancing using ribbon. Everything is taken care by that proxy, right? So can I say that this proxy is acting as a gateway to my microservices? Yes. The external client can never invoke my microservices directly. They have to hit the proxy, and proxy is acting as a API gateway, I can say, right? So we need something like an API gateway which can act like a proxy to my microservices. So why should I develop such an API gateway? So Netflix has a component called as Zool. So we can use or we can leverage Zool for this purpose, right? So Zool can act like a proxy which can internally look up Eureka, use Ribbon for load balancing, and of course it can internally use Hystrix for identifying what is the status of circuit for this particular service, everything. Zool is nothing but an API gateway provided by Netflix. So do you want Zool to be used for internal service to service communication? When service 1 wants to hit service 2, do you want to use Zool? No. Zool is only for exposing your microservices to external clients, right? So hopefully you understood what is the role of Zool. Okay. Now let me move on to the next one. What is the need for a configuration server? Basically, let me explain you. Let's assume that in my application, I have a lot of services from service 1 up to service 2, service 20. There are a lot of services. Each service will be having its own configurations. Normally, we externalize the configuration to a .properties file, or if you are using Springboot, you'll be externalizing your configuration to a .yaml file. So normally in Springboot, if you are using, you'll be writing a file with name application.yaml, which contains the service related configuration, right? Now, if you are using something like Springboot to develop your microservices, each microservice will be a .jar file basically, right? And this .jar file is bundled with the .yaml file. So every service is bundled with its own configuration, right? So if tomorrow, if I want to actually change any of my microservice configuration, again, I need to change the YAML file and rebuild my application to get a new jar file with the YAML file. So if I want to modify any such configuration, again a rebuild is required. That rebuilding of my application is required. Not a good idea. So bundling your configuration also inside your microservice code is not a good idea. So idea is, if you can keep all the configuration for all of your microservices in a centralized repository kind of a thing, then there will be only one repository where I need to modify if I want to modify any configuration of my microservice, right? So let me extend this idea. Can we use GitHub? Yes. So it's a good idea to use GitHub repository. Let's assume that I configured a repository in my GitHub, and in this single GitHub repository, I'll put all the configurations for all my services. But again, I need to follow some conventions. Let's assume for service 1, let's assume service 1, name of the service is S1. I'll follow some convention. For S1, I'll create a file with name s1.yaml. But for S1, I might be having multiple profiles. I might have a different configuration for development, production, etc. Right? So for S1, I'll have a file with name s1-dev.yaml, which contains my development related properties. S1-prod, which will contain my production related properties. Like that, I'll have multiple YAML files. Similarly, for S2, I'll be having something like s2.yaml, s2-dev.yaml for development environment, and s2-production.yaml. Like that, I might be having multiple YAML files following such a convention in my GitHub. Now, actually whenever my service 1 is starting up, I want to get its configuration from GitHub, and using this configuration, it has to boot up. Is it? How can S1 get the configuration from GitHub? Can I use GitHub API in my service code, get the configuration and then use it? Not a good idea. Maybe today I'm using GitHub. Maybe tomorrow I might be using some other repository like SVN. Again, I don't want to change my microservice code if I want to go with something like SVN, right? So the good idea is, instead of my services talking to the repositories, it will be a good idea if I can have something called the configuration server, or I'll say simple config server. This config server should know how to talk to Git or maybe SVN, right? So I want a separate config server. Oh, what is this config server again? I would say that config server is nothing but a REST API. REST API means it should expose some endpoints. So basically, Springboot provides a configuration server, which is nothing but a REST API. It exposes one single URI, something like /app name /profile. Basically, the configuration server will be exposing a single REST endpoint following this pattern /app name /profile. Now, whenever S1 is booting up, whenever S1 is starting up, what it can do is it can make a REST API call to this URI. So whenever S1 is starting up for production, you might have activated a production profile in your S1, right? So if you are starting S1 with production profile enabled, what S1 should do? It should make a call to config server using /app name is what? S1/prod. Now the config server will understand, okay, the client is requesting for configuration of application S1 for production profile, right? So config server will use Git API to get the configuration of S1 for production and give the response. Then S1 will use its response, load all the properties, and then start itself, right? Similarly for S2, whenever S2 is starting up, S2 also should make a call to what? What is the URI for S1? S2. Suppose if you are starting S2 in development environment, S2 should make a request to what? Request to config server using S2/ service name is S2/ dev. The profile is dev /S2/dev. Is it? So config server will understand, okay, I need to give configuration for an application with name S2 for development profile. It will give the configuration response, and using that configuration, my S2 should boot up, right? So actually what I am trying to say is, every microservice has its own configuration. Instead of bundling the configuration along with microservice, if we can keep all the configuration at a centralized location like GitHub, we can use some configuration server to serve the configuration whenever required. Yes, that's a good idea. Tomorrow, if I want to change any of the configuration for any of my microservice, I'll come and change at a single point, right? So that is the use of config server. Actually, there are a lot of other users. There are a lot of other use cases also in config server. But hopefully for our discussion right now, this is a good startup and we understood about config server. There are a lot of other configurations as well. Okay. Okay. Now we understood about what is this configuration server. Now let us try to understand what is this sleuth and how it can help in microservices. It's a very good tool, a very good tool to understand. Let me tell about one problem. Okay. Let's assume that I'm developing my application for an e-commerce application like Amazon or Flipkart. Let's assume that I have a service called as order service, which is actually taking orders. Whenever new request comes for order service is writing a log, right? Every microservice will be writing logs. But what if my order service is having 10 instances? 10 instances, if they are all writing logs in 10 files, it is really difficult for me to actually view the logs. If there's any problem, I cannot really analyze the logs properly, right? So basically, what we need is we need a centralized location where I can see the logs, right? So basically, when we are implementing microservices, what we do is we use a separate logging server. So it is not a good idea to make your microservices to write logs to your files. Rather, you can make your microservices to stream your logs to some logging servers. Never write logs to files in microservices. Better idea is to stream your logs. How to stream your logs or where to stream your logs? What is an example of a logging server? If you might be knowing a popular logging server like Logstash. You might be using something like ELK, Elasticsearch, Logstash, Kibana. We can use that. So what we can do is we can make my Logstash to listen on some IP colon port for logs coming in some particular protocol codec. All my microservice instances will be sending logs, will be streaming the logs to this IP colon port, right? The logging server will persist the logs, right? But if you want to search the logs in a faster way, do you want logs to be indexed? Searching will be faster if we can index, is it? What we can do is we can use Elasticsearch. We can make Elasticsearch to point to Logstash. Whatever logs are coming to Logstash will be given to Elasticsearch, and Elasticsearch will generate index files. Indexing will be done so that the faster searching can happen. But Elasticsearch will just create index files. But it does not have a UI for searching logs. Now what we can do is we can use Kibana. Normally we can use such things like Kibana. We can make Kibana to point to these index files. This Kibana has a very good UI where we can search for logs. Kibana will be internally using indexes whenever we search for logs. Kibana will show your logs in a very good UI. And if you're having a lot of services like search service, order service, all the services will be streaming the logs to same IP colon port. So all the logs of our microservices we are receiving at one place, and we can view all the logs of all of our microservices using Kibana. So I was able to centralize my logs in ELK stack. Yes, I took this ELK stack as an example. We could use any other tools like Splunk as well, right? So we can actually integrating our microservices with ELK stack. I'm able to see all the logs at a single place in Kibana UI. But that doesn't solve our issue. Using ELK stack, we are able to get all the logs in a centralized location, but that is not going to solve our issue. What is the next problem? Let me elaborate. Let's assume that we have an order service. Whenever order is coming, let's assume that order service is writing a log. In the log, let's assume that it is logging the order ID. Every order which comes into my system, for every order, a unique order ID is generated by my order service. And whenever it is writing a log, it will also write order ID. Now, let's assume that order service is calling service 1 and this is calling service 2 and service 2 is calling service 3 for doing the order processing. That means whenever a new request comes, order service will call service 1, service 1 will call service 2, service 2 will call service 3, then the order is processed. Now, our system is getting a lot of orders, but we want to actually track what happened to an order with ID 100. We want to track or trace the logs of order service, service 1, service 2, service 3. All these logs are actually coming in Kibana UI. You can see all the logs, but these logs might be for a lot of order requests. I might be getting some 1,000 order requests. All the logs for all the 1,000 requests are centralized. What I want is somehow I wanted to trace only the logs which were generated while processing an order with ID 100. How to trace the logs, right? So we can use a tool called as Sleuth for this purpose. What is the idea, right? So basically in your microservices, if you're writing using Spring or Springboot or so, you'll be using some frameworks like logs, log4j or logback, etc. Yes. So whenever you are writing logs using log4j or so, what you do in your code for writing a log, maybe you'll write something like logger.info, logger.debug, etc. right? In your code, just write it as usual. No changes in writing logs. But if you add Sleuth as a dependency in your Springboot application, what will happen is whenever a new request comes, Sleuth will automatically generate something called as a new trace ID and span ID, and keep this trace ID and span ID in the current thread local object. Okay, and most of the frameworks like log4j or logback, they can be configured to write logs using this trace ID and span ID which are present in thread local. We can specify the pattern. So in all my logs which are generated, I'll configure my logs to be printing trace ID and span ID. But actually, who is generating this trace ID and span ID? Sleuth. What all I have to do? I don't need to write any code. Just add a dependency of Sleuth in service 1. It automatically generates. Now, whenever service 1 is making a call to service 2, right? if you are having sleuth here, what sleuth will do is it automatically add this trace ID in the request header and then make a request to S2. So whenever S2 receives a request, okay, it will identify that there is a trace ID in the header, right? And in S2 also, in the service one also, I have a sleuth. The sleuth which is running inside the service 2 will be able to identify that there is a trace ID in the request, and now the sleuth in the service will not generate a new trace ID. It will just log, it will just use the same trace ID, but a different span ID will be generated, right? So in this service, whenever you are writing logs, automatically this trace ID and span ID will be written in the logs. Is it? But don't you think that trace ID is same in both the logs? Right? Similarly, when S1 is making a call to S2, what sleuth in S1 will do? It will add the same trace ID header in the request and it will send. Now here in this S2 also, there is sleuth. What it will do is it will identify the trace ID in the incoming header. It will not generate a new trace ID. It will use same trace ID in the logs. That means for one single request coming to this order service will generate a new trace ID for the first time. And same trace ID is used by all the logs in S1, S2, S3. Is it? So now what I can do is in my Kibana UI, all the logs are coming to Kibana, right? So in my Kibana UI, what I want to do is, let's say I want to search the logs only for a specific request with ID 100. First, what I'll do is I'll go to Kibana UI and search for order ID with ID 100. I'll get the logs. In that logs, I will take the trace ID. Now in my Kibana UI, I'll search based on trace ID. Will I get all the logs where this is a trace ID? Yes. So am I able to trace the requests particular to particular request? Yes. So that's where sleuth will help you in tracing the logs. Really, this is a very good tool whenever we are implementing microservices. Tracing the logs helps us in identifying any problems or bugs in our application. So sleuth is a very good tool to trace your logs. So I think now time is almost 8:36. I mostly covered my agenda. I want to dedicate the rest of the time for question and answers, right? So maybe I will take, very good question actually, span ID. What is the use of span ID? I got a very good question. I'm taking the questions one by one. First of all, I'll take this question. What is the use of span ID? To be very frank, in case of sleuth, if I'm using only sleuth for log tracing, span ID is of no use, right? Actually, there is one more tool which we use in combination with sleuth called as Zipkin. Okay, Zipkin is actually used for analyzing the logs. Okay, since somebody has asked me about what is the span ID, let me elaborate about how we can use sleuth in combination with Zipkin to analyze our logs. Okay, let me just tell you what is Zipkin. Firstly, let's assume that I have service 1, service 2, service 3, service 4. Whenever new request is coming to service 1, sleuth in service 1 will generate trace ID. Let's say trace ID is ABC. It will generate one span ID. let's say initially, since the first service in the call is service 1, trace ID and span ID will be same. Then S1 is making a call to S2. So sleuth will send the trace ID ABC. Now S2 will use trace ID again as ABC, and span ID will be something different, right? Again, whenever S2 is making a call, trace ID will be ABC, but span ID will be 456, some different value. In S4 logs also trace ID is ABC, but span ID will be something, right? Now all the logs are coming to my Kibana UI. That's fine. Now I will introduce another server called as Zipkin. Zipkin is a server which will be running on some port. I can run I can run the Zipkin on some IP call port. And what I have to do is in S1, I have to add a software called as Zipkin client. Now Zipkin client, what it will do is it will be running inside my S1, right? Whenever a new span is generated by sleuth is generating span ID, right? Zipkin will send that span information to Zipkin server. Zipkin client will send the span information to Zipkin server, right? Similarly, the Zipkin client on all the services will be sending information about when the span started, when the span ended, when the span started, when the span ended. So Zipkin will be able to get information about when a span started, when a span ended, right? Now, if I know how much time, at what time the span has started for S2 and at what time it ended, can I know how much time this S2 has taken totally? By calculating the difference between span start time and end time? Yes. So by actually analyzing the spans, the Zipkin server what it can do, it can identify the time taken for S1, for S2 to serve the response. So if one of the service is slow, right, will we be able to identify by using the span information on Zipkin server? Right? So every service will be sending span start time, span end time to Zipkin. Right? Zipkin will store all of them. By using that information, Zipkin will be able to give you a graphical view of how much time each request has taken, and will be able to identify if a particular service is slow. So it's used for analyzing the logs. Hope this answers your question. Basically, span ID is for log analysis by Zipkin. Okay. Yeah. Any other questions I can take right now? How to handle transactions in microservices, right? Very good question, Eknath. Let me discuss about how to handle transactions in microservices. Very good question. So basically, if I have multiple services, service 1, service 2, service 3, service 4, let's assume that these are part of a single monolithic application. So what will happen whenever a new request comes to S1? Since they are part of a single monolithic application, I can start a transaction in S1, maybe a database transaction I'm talking about. I start a database transaction in S1. Service 1 may call service 2, all this, and I will end the transaction in S1. So the service 1, service 2, service 3, service 4, if they're making any database modifications, all these modifications can be part of single transaction. And if any exception is there anywhere, I can actually roll back the transaction. If you are having a single monolithic applications, transactions work. But in case of microservices, one problem, biggest problem of microservices is transactions won't work. We cannot have a single transaction spanning across all the microservice calls because service 1 might be using a different database, let's say Mongo. Service 2 is using Cassandra. Service 3 is using Oracle. And they're all individual services. We cannot have a single transaction spanning across multiple services. This is one problem with implementing microservices. So I can just use one statement saying we cannot achieve immediate consistency in microservices, but we have a workaround alternate. We have to go with something called as eventual consistency. Eventual consistency, right? So microservices cannot guarantee immediate consistency. When you're going with microservice, you will never get immediate consistency, but you have to go with the concept of eventual consistency. What is this eventual consistency? Let me explain how we can achieve eventual consistency, right? So let's assume that there is service 1, service 2, service 3. Let's assume that there are 3 services as of now for simplicity. Every service might be, whenever it gets any request, it might update its state in a database. So whenever any state change happens in a microservice, it has to publish an event. Maybe event, for using events, you can be using messaging. So whenever there is a state change in service 1, that means whenever there's a database change or whatever it is, service 1 will publish an event. Okay, something has changed. Then service 2 might be interested in that event, take the event, process the event, and if something has changed in service 2, it has to publish an event, right? And S1 might be interested in that event, take that event, and then update itself. Basically, the services has to use messaging internally to communicate any state changes. Suppose if S1 has updated its database and has published an event, S2 has to take it, but while processing that event, let's say there was an exception, some problem has occurred. S2 will publish an event saying that some problem has occurred here. S2, whenever it gets an event that something has occurred, maybe S2 will take that event, has to execute some compensating logic which will revert back the database to the previous state, right? So basically I would say that these microservices will communicate with each other using events, and they can achieve consistency not immediately but eventually. So I just show you one small PPT with a diagram for this. Just a minute. Just open a small PPT to explain this diagram. Small use case I have. Yeah. Take an example of a simple use case. Let's assume that I'm implementing online e-commerce based application. Whenever order comes to my application, let's assume that order service will take the event. What it will do is it might have created an order in its database. That means the state has changed. Order service will publish an event called as order created event. Okay. Once order is created, let's assume that whenever order is created, I want to do the payment processing. Assume that payment service will take this order created event and then do the processing, right? Once the payment is processed, if the payment is successful, assume that payment service will generate an event called as build order event. Okay, now the order is built. Stock service can take this event and check if there is available stock. And if the stock is available, then let's assume that stock service will push another event, will publish another event called as order prepared. Once order is prepared, let's assume that delivery service will take it and it will publish order delivered event once order is delivered. Then the order service might be interested in this order delivered event and update its database saying order status is delivered. So these services are communicating with each other. Whenever there is any state change in the services, they are communicating with each other using events. Now I showed you a successful flow. What will happen if there is some problem? See another screen. See here, order service has created an event, payment service has taken it and processed the payment. Once the payment is done, let's assume that it pushed another event called as build order. Now the stock service is taking it, but let's say stock is not available. If the stock is not available, stock service, what it will do is it will publish an event called as product out of stock event. Now for this event, my payment service might be listening for this event. Oh, stock out of service. Then what my payment service can do is can execute some compensating action which will revert back the payment, right? Payment service has taken this event and has reverted the payment. Then the order service will take this same event. It can also be subscribed for the event. Then it will update the status of order as appropriately. Let's say stock not available, order cancelled, right? So like that, the services can interact with each other through events. And are we achieving immediate consistency in this case? See, payment will get reverted back, but eventually, right? So this is a very good example normally which I use to tell that in microservices we cannot achieve immediate consistency, but we can achieve immediate consistency. So maybe due to some time constraint, I'm just quickly rushing out here, but I hope you understood the question, right? So I got some more questions. Let me check some questions. Any beginner in Spring, how can I learn the methodologies of? Okay, I got a question. How can you learn means there are a lot of resources available. Maybe I can suggest you some books, very good books which are available. There is not a single book. I cannot say this book is sufficient, but best thing I would suggest is go to microservices.io. There are some patterns. There will be discussion on patterns in microservices.io. There's a person called as Mr. Richardson who has written a lot of microservice patterns. He's a very famous author. You can just go to microservices.io and just go ahead and read about all the microservice patterns. That will be a good start. Subramanian, okay, you are asking a very good book. I have read a lot of books. Actually, I can say that there's a book called as Microservices Using Springboot by an author called as Rajesh Harvey. I have seen his book to be very good. So I would recommend you to that book. Just Google for microservices using author name Rajesh Harvey. Then I got one more question. Let me check. What is the container good for microservices? Okay, actually, I didn't talk about microservice deployment topologies in this webinar, but if I have to talk about microservice deployment strategies, definitely I would say that we need our microservices to be running inside a container, isolated container, which provides a runtime for running my microservice. So there are a lot of technologies like Docker, Kubernetes, or you can use any other technologies to containerize your microservice. So most popular tool which many people use in the organizations is a combination of Docker and Kubernetes, or you can actually go for some PaaS, a platform as service like Cloud Foundry or OpenShift, etc. Okay. Okay. Subramanian. Okay. Rajesh RV is the author name. Okay. Yes, learning Springboot. I think, yeah, correct. I've got one question from Aravindan. For convenience, what is it saying? How do we provide resiliency of Eureka crashes? Very good question, Arvindan. Actually, Eureka is a discovery server, and if that Eureka crashes, can I say that it is a single point of failure? No. Only thing is, actually, new services may not be able to register, but existing services will still keep on working. My application will never be down just because if Eureka is down for some time. All my microservices will be running. Only thing is, new microservice instances will not be able to register. And also, if one of the microservices goes down, Eureka will not be able to monitor heartbeats and all. Normally, to provide resiliency for Eureka, it is recommended not to have a single Eureka instance. You will have a cluster of Eureka instances. So if one Eureka is down, other Eurekas will be able to take care, right? To answer your question, actually, I would say that you have to create a cluster of Eureka instances. But again, there are a lot of configurations and all about how to actually configure a cluster of Eureka instances. When you have a cluster of Eureka instances, again, there might be questions. Like suppose if I create a Eureka cluster of size 3, and there might be questions from your side, like if there's a microservice 1, do you want service 1 to register with all the 3 Eurekas? Might not be, right? Again, there are some patterns which we need to follow while registering, etc. But to answer your question straightforward, yes, we should be able to configure Eureka cluster for achieving resilience. Okay, again, I have one question from Azugesan. Is it advisable to have a single DB? No, definitely never have a shared database across your microservices. See, the first point, if I have to define a microservices, every microservice should be independently manageable, independently scalable, independently deployable. Basically, every microservice should be independent. There should not be any tight coupling between microservices. So if you are having a shared database, when service 1 is updating a database table, and if it is affecting another service too, definitely it is not good. You are having a tight coupling between your services. So definitely the good practice is don't have a shared database, right? And if I have to put it in a different way, I can also say that, let's say you are having one single database server. In one server, can you run n number of database instances? Yes, right? So for each microservice, dedicate one database instance, separate database instance. It is advisable to have a separate database instance for each microservice. Maybe on a single server, that's okay, but a different instance. Okay. Any other queries I can take up? We have 2 more minutes. Hands-on, actually I wanted to show you one hands-on, but right now it was not possible, so I will give you my link for hands-on. I will actually post something. Let's say I cannot show right now, but I will post a link for hands-on with my exercises after this webinar. You will get a link maybe with the download links for exercises and a small documentation of how to actually run a microservice, register it, everything, right? Okay, thank you. So I hope this session was useful to all of you. Exceptions you're asking, right? Every microservice has to handle its own exceptions. Again, it's specific to microservice. Okay. So thanks to all of you for your time and joining the session. Hopefully, I tried to give as much as possible in this 2 hours. Maybe if you want to more, maybe if I can give a dedicated training, I could spend more time and give you a very nice training. I have different use cases for it. Thanks all of you for your time. Have a good night.